In this video, we will learn about the quantum mechanical model. So before going into the details of quantum mechanical model, about its postulates, we will learn about a term known as wave function. So this term is used in quantum mechanical model every now and then. This term describes about the electron and is denoted by psi. So to understand the significance of psi, we will consider a simpler mathematical equation, that is the equation of a straight line y equals to 4x plus 3. So here the value of y gives us the information about the slope and also the coordinates or at which the slope will intersect the y-axis. Similarly, a wave function gives us information about the energy of the electron, the position of the electron, and the velocity of the electron. But this expression does not give us the information about the electrons. A slight modification in this expression gives us all these three informations about the electron. So the core idea of the wave function is that it describes about an electron in a region of space. As we have already seen that an electron is described by the wave function, here we will see another equation that gives us the energy of the electron. So that equation is called the Schrodinger's equation. So the wave function psi multiplied by an operator that is known as an Hamiltonian operator, which is a mathematical operator, gives us the energy of the electron. So the equation can be stated as Hamiltonian operator multiplied by the wave function psi is equals to the energy of the electron. So we can say this equation as H psi is equals to E psi, and this equation gives us the energy of the electron. As we have seen how we can use the wave function to find the energy of an electron by using the Hamiltonian operator, now we will look at how we can use the wave function to find out the position of the electron. So we will take the modulus of the wave function and then square it. So this will give us the probability of finding an electron at a position. So this expression will give us the relative chance or the probability where an electron can be found in any region. So this is the main difference between the Bohr's model of atom and the quantum mechanical model. So in Bohr's model of atom gives us the exact location about an electron, but in quantum mechanical model it only gives us the probability of finding an electron in a particular position. So we have seen that the modulus of psi square gives us the probability of finding an electron. So to visualize this, we use a tool named as the boundary surface tool. So what is this boundary surface tool is? So in any region of space, different regions will have different probability. Some region may have a high probability of finding an electron. In some region there may be low probability, while in some region there may be zero probability of finding an electron. So to visualize this plot, we use a simple metric, that is, darker the region, greater is the probability. So a region that is shaded darkly has a greater probability, while the region in which it is shaded lightly has lower probability, while the region that are unshaded has zero probability of finding an electron. So here is an image showing the different probabilities. So in this region there is a greater probability of finding the electron since it is shaded darker. Here in this region the probability of finding the electron is less since this region is shaded lighter, whereas this region has a zero probability as it is unshaded. As we have already learned about the boundary surface plot, so here we will learn about two different terms which tells us where the electron can be found and where it cannot be. So the two terms are orbital and node. A orbital is a region in the space where there is a non-zero probability of finding the electron. So the probability may be greater or may be lower, whereas a node is a region in space where there is zero probability of finding an electron. So in a node we will never find an electron, whereas in orbital we will find an electron in various amounts. In some we will have a greater probability, whereas in some we will have a lesser probability. However, this is the theoretical definition of orbital. In order to visualize an orbital, let us consider the boundary surface plot. So this is a boundary surface plot. Here in this region it has a greater probability, while in this region it has a lower probability. So the region with greater probability of an electron is considered as an orbital. So in this case this is an orbital and this part is an orbital. So this part where the probability of finding an electron is lower is not considered as an orbital, whereas this part is considered as the node.